Hey everybody, let's talk today about arrays. So we've got the setup that we built from the other day that has our lights, and we got a button. But I really want to talk about arrays today and see if we can nail that down. So what I'm going to do is I'm going to make an array that will hold each one of these pins that have lights connected to it. So you can see digital pin 3, 4, 5, 6, all the way to 13. Let's go ahead and make that. So I'm going to say int because I will be storing integer numbers, and I'm going to call it LED pins, and then I'm going to put a square bracket, and I'm going to put in this square bracket how many pins I want to have. Well, I have to go 3 to 13. So that should be 11. You can see I've got 11 different lights there. So I'll put 11 inside these square brackets. So now what I've done is I've created by using one variable, I can now store 11 different pieces of information in that single variable. Let's talk for just a second about what that is. All right, so what I've got here is a kind of a visual representation of memory in the Arduino. And when we start up our Arduino, our program is going to use these different slots, each one of these different slots that can store information. When we write an int, say we make, so we say int pin equals 7, let's just say. Well, let's talk about what actually happens there. Somewhere in the memory, this 7 is going to be written right there on that memory. And this pin here, this variable, remembers where it is. Okay? Now, it's going to be stored in binary, and we'll talk more about binary with a later project, but basically that's how that works. Now let's talk about what happens when we make an array. Well, when I make an array, then what I need to store when I create it, notice I'm not using an equal sign, is I need to use a square bracket, and what I'm storing is the size of the array. And so somewhere in my memory, what's going to happen is we're going to section off some pieces of the memory. Now, when I say 5, 1, 2, 3, 4, 5 of them will be sectioned off. And pins will now reference this starting little piece of the array in memory. And so now I can write different numbers here because it's a type int, so it's going to store numbers. And each one of these different positions have to be referenced by their position in the array. So what I'll do is I'll start with the name of the variable, say pins, bracket 0, because that's the first position. A lot of times in computer programming, we count with 0 as the first number. So if I put, say, a 3 or something like that in there, then it knows that it's going to go to the location pins. Pins told it to start there in the array, and I'm going to write the number 3 at the beginning of the array. Likewise, we could also in our code say something like this: pins bracket 3 equals 7. So what is that doing? Well, again, it's going to start, pins is going to reference that first location, but it's now going to count over 1, 2, 3. So the first block is block 0, then we block 1, block 2, block 3. So that's actually going here. And that's that location. And we can write a 7. So when we created the array, begs the question, what did it put in these different places when we started making them? Well, it put zeros, because it's got to put something, right? All right, so let me ask one more question. If this here is pins bracket 0, that's 1, 2, 3, 4, then what would pins bracket 5 be? Well, we did not declare that to be part of our array. So what pins 5 is going to do is it's going to start right here where pins is, and it's going to count over 1, 2, 3, 4, 5 blocks, and it's going to go here. Well, what is that? I don't know. It could be some other piece of memory that's stored some another time. It could be a 0. Who knows what it is? So we don't know what is after what we stored in our array originally. When we said 5, we only get 5 blocks, and they're filled all initially with a default value of 0, which we can then write over, and we can access them. The way we access them to get the value that's stored in there is we simply say, well, I want to get that 7 I put in, well, then I just put pins bracket 3, and wherever I use that, that's now a 7. But pins bracket 5, well, that's not a good idea because that could be anything. Some of the more modern programming languages do not allow this. For example, Java does not allow you to try and access something outside of an array. Okay, so let's go back to what we had before. Looking at our code here, we have an array now of 11 blocks that we sectioned off for our pins, but they're currently all stored as 0. They don't have the pin numbers that we want to put in them. So I think our setup code would be a good time to do that. We could do it outside of the setup method if we so wanted to. We could do it up here. Right? But, LED pins. But let's do it inside the setup. Well, our first pin here, I'm going to say that this is my first pin, and that is connected, that LED is connected to pin 3. So I'm going to put that there. Remember, the first block in an array is 0. And we're going to go forth like this. So each one of these different blocks in my array is getting a different digital pin assigned to it. So the pins for my LEDs go up like one at a time, just like so. And that's all of them. Remember we created 11 different blocks. So the last block in our array is number 10. Since we started at 0, that does make 11 different sections where we can store the information. When I look at this though, don't you see the repetition here? Arrays work really well with loops. So I recommend you pause the video right now and try and rewrite this code here, where we set the pins from 0 to 10 using a loop. Okay, let's see how you did. I want to start counting at 0 and count up to 10. So I'll start at 0 and go up and continue my loop while x is less than or equal to 10. And I will increase the value of x by 1 each time. And then I will say LED pins, and I'll put a 0 here. And I will, sorry, not a 0, an x there, which starts at 0. And I will be starting my pin numbers at 3. Well, that's the x value plus 3. So we're going to store into the slot x the value x plus 3. That's one way you could do the loop. We could also do a while loop. So maybe you thought of making a variable like this. And then you can say while x is less than or equal to 10. Of course, we need to make x increase. So you could have done it something like that with a while loop, or just a for loop like I did before. Now I'm letting my variables for my for loop count through the pins all the way from, the blocks in the array called LED pins, which begins at 0, and the last block in the array is 10 because there's 11 of them. Maybe you had yours start at 3 and go up through 13, and you stored it into something like that. But somehow you need to have this relationship where the section in the array is one less than the one in the pin. I'll take it back to the way, starting at 0 and going to 10. That's just how I saw it. All right. Well, now I think we're ready to go in and turn on all of our pins as output. We need to do that in our setup. So again, we can say LED pins 0, you need to be pin mode. LED pin 0 should be an output. Pin mode LED pins 1 needs to be an output. Again, though, we're going to have to do this for all of our array. And that's just silly, isn't it? So let's use another loop. I'll use a for loop. I can use x again because I used x. I declared it in my for loop. Once I'm done with my for loop, x is available for me to use again. So I will use it. And I can say LED pins, pin mode, LED pins, x becomes output. There's another thing we can do. Since we're creating the pin numbers here using x, let's just take this out of here and put it in that loop right there. Now it takes care of both with one loop, a little bit faster. So the LED pins array is getting the values that we want, the value of each pin, and we're being set to output. All right, let's make a loop. There's our loop method. It will be called over and over and over again. I'm not really going to be using it so much as a loop, though. I just want to practice calling different places in my array and using it. So we need to say digital write. And we could simply say digital write and give it pin 3 if I want to turn on this LED here, but we're practicing using arrays. So I'm going to say digital pin, LED pins 0. That's the one I want to turn on. And I'm going to set it to high. And you can see that that is indeed the one that turns on. Well, what if I want to turn this one on over here? Well, that's 0, 1, 2, 3, 4. So I'll stop the simulation and I'll put in a 4 here. And we should see that light turn on. Okay, what if I want to make them, do our different light show? Well, I can certainly do that as well. I'm going to make the lights go forward and then come back. So I think I'll say for int x, I can use x again, equals 0, x less than or equal to the 10, which is the last number in my array of size 11. And I'm going to say pin mode LED pins X, not pin mode, I'm sorry, digital write. We need digital write there. LED pins X to high. Then let's put in a delay of 100. And then let's go ahead and turn off that LED. We could leave it on. You know what? In fact, let's leave it on. So when we do this, we should see each one of the lights slowly turn on. And then once they're on, they're going to stay on. Perfect. Now after they turn on, maybe we could have added a digital write LED pins X low so that it turn on and then off for the next one. But let's make them count back down now. And so I'm going to say int, I'll use a different letter this time, int y, and I'm going to start it at 10. And I'm going to continue looping while y is greater than or equal to 0. And I'm going to make y count down. All right, so let's make them turn off now. Digital write LED pins bracket y goes low. Because we have y minus minus, the y values are going to count down. They're going to start at 10, and it's going to continue doing this code as long as the y value is greater than or equal to 0, and they're going to count down. We do need to go ahead and put a delay in there, or they'll just turn off immediately. And let's take a look. And then since loop is called over and over and over again in a loop, we should see that code running constantly. All right, so what I want you to do, though, is I want you to practice turning on different lights by calling it using the pin numbers assigned to our LED pins array. So see what you can do with that. Okay, so play around with arrays, play around with loops and variables, see what you can come up with this, and look for the next video in our series. All right.